So students, today we are doing dimensions analysis questions. There will be series of questions. Maybe I have 12 to 12 questions with that. So each question will be different from one another, but maybe you will learn something from the question, each question. So what you have to do is stop, like when you do the questions, when the question appears, just stop there and do the question and then go through the guide. So otherwise, I will be explaining it right after the question, right? So remember that, don't just go to the explanation. You have to do the question, try the question first, right? That's a must, right? You should know whether you can do the question, and when you are doing the question, a problem will arise. If you cannot do the question, then the answer will be there, then it will resolve itself, right? I have to understand what I'm saying. So that's the method, right? Just try the question and then go through the explanation. You will learn something new for sure. So let's try it now. Right, we are starting with our very first question. In the equation, F equals KAV, F is force, A is radius, and V is a velocity, and dimensions of K, right? So in the question, F, so force ml T minus 2, you should know this. Then that should be equal to K into A, that telling is a radius. So that's an A, that's an L actually, L value, right? That's a length. Then V is velocity, it's LT minus 1. So K into, we get L squared T minus 1, right? So for this K will complete the equation. Remember, right hand side should be equal, left hand side should be equal to the right hand side. So this side should be equal to the other side. So we have L squared, that's in this side actually we have only L. So that means 1L should be removed from this side. So it has to be L minus 1. At K it has to be L minus 1. Then L minus 1 into L squared, it will be L then. Right? I hope you understand. And there's no M here, so we need M. And what about the time? Yes, we have T minus 1 here, but on the other side we have T minus 2. So we need another T minus 1. So once this is multiplied by this value, we get ml T minus 2. So ml, so we are looking for ml minus 1, ml minus 1, and T minus 1. That's the fourth answer. Right, moving into the question number 2. Right, which of the following is a dimensionless physical quantity? Uniform velocity. So they are asking us to find which is not a dimensionless, so no dimensions, physical quantity. Uniform velocity. So velocity basically it's LT minus 1. We all know that, right? Coefficient of friction, that's mu, right? F equals mu R. Here R, it's a force. Here F, it's a force. So mu basically F divided R. So force cancelled by force. So mu, yes, no dimensions. Even though we get the answer, let's check the others as well. Change in momentum, mv. So even it's delta mv, the difference will still, we will have the dimensions. If only we divide certain values, then only dimensions will cancel. We remember that. So correct. Relative velocity, again it's a difference, right? v1 minus v2, so again no change. Uniform acceleration, again it's acceleration, LT minus, so we have the answer, it's the second answer. Right, moving into the third question. Right, this question, in the equation F equals A sine CT, okay, V cos dx, where F force, right? So F, we know ml T minus 2. These things you should know, right? And then X is displacement. What is X? Yeah, here. Right, let's write it down first. A sine CT bracket plus capital B cos capital dx, right? So then we are getting d, here d, right? X, right? X is the displacement L, and t time, as we have t, yeah, that's simple, t, okay. And the dimension of ratio A over B and C over D, right? Let's start with A over B first, right? First thing you need to know the dimension of sine values. Basically sine value mean opposite divided by hypotenuse, that's L divided by L. So no dimensions for sine and cos values, right? Only A and B will have dimensions. So that means the dimensions of A, it has to be, so no dimensions in this one. So that means the dimensions of A has to be equal to dimensions of F, right? Because when adding, dimensions must be equal. Remember these things. When adding, dimensions must be equal. So dimensions of this value should be equal to dimensions of this value. Then only we can add them, and both should be equal to 4, right? So dimensions of, basically A is 4. So dimensions of A, it's MLT minus 2. Again B, you don't have to write actually, MLT minus 2, same dimensions, cancel off, so no dimensions. So AB ratio, we get no dimensions and we get no dimensions. Moving into the C over D, right? It's C over D, right? Right, C over D. Then where's C? Right, here we have C. Again remember that when it comes to angles CT here, so in angles, even sine, let's say radian angle or whatever the angle is, radian angle, radian theta means SOR. I hope you know these theories. So this is S, this is theta, and R is this. So SOR, again displacement divided by displacement, we get no dimensions. So that means CT has no dimensions. So dimensions of T should cancel off by dimensions of C. So T cancel by T minus 1. So dimensions of C, it has to be T minus 1, right? And dimensions of D, right? Again the same principle we can apply. CD, the dimensions of it was dx, right? Dx. So dimensions of x is L. So to cancel that one, we need to have L minus 1. So for C we have T minus 1, and for D we have now it's L minus 1. So basically it's L T minus 1, right? That's what we are getting. Let's move into answers. LT minus 1, yes, M naught, there's no M. So M naught, LT minus 1, that's our answer. Third one. Alright students, now we are moving into our fourth question. Actually this is not from dimensions, so I hope you can see it actually. This question from units, right? Actually it's about measuring instruments. So a student uses a certain measuring instrument in laboratory to measure diameter of a small glass bowl, right? So they take diameters from various points, right? Diameter of small glass, a reading obtained for different instances. So take this side and to take from this side. So what we have to do is we have to collect all the values and we get the mean value. So we have to add them and divide it by 4, right? We have 4, right? The least count of the instrument and the diameter of the bowl could be, right? So what basically we have to do, we have to add all these. So let's start adding. Alright, I'm gonna add them. Okay, now 2, 2, 4, 4, 7, 11, 2, 13, 1, 1, 2, that's okay. 1, 1, 2, right? Okay, we have got 1, 2, 3, 4, right? 40, right? What we have to do is 40.23 divided by 4. It's 10.2 divided 2. So it's 0. It has to be 5, right? Yeah, 5. And 34, we get 7. 10.57, right? We don't have 10.5, of course, so we can round up it to 10.06, right? Yeah, and we have 10.06 here. We have two answers. Hope you can see it. 10.06, 10.06. And the least count, they're asking us to find the least count. So least count, see, the least amount they have taken is 0.02 here. Here it's 0.02 here. Here it's 0.07 here. And this one 0.02. So what I can conclude, they can measure 0.01 as well. So that's the least count. So it's the second one, right? I hope you remember the method we did. Actually, practically what we do is when we need to find the diameter of a glass tube, glass bowl, whatever it is, we take the readings from various points, like here 1, 2, 3, 4 points, and we take the average value. Right, students, we are at the fifth question now. Units and dimensions. So in the equation, we x this, where x is displacement. Let's write it down. X is displacement. So we basically we have L square, and v velocity. Where's velocity? All right. The outcome v is velocity, right? Okay. LT. Can't say this right. LT minus 1. In the root we have L squared, and then K over mass, right? Physical quantity, yes, depicted by K would be. Let's find the dimensions actually, then we can find the unit. So when so inside root we should have L squared and T minus 2. Once we get the root value of this, we get LT minus 1. Correct, right? Yeah, that's how. So here we already have L squared, so we don't need it from K, and we don't have mass M, so that has to be cancelled off. So again in K we need to have M minus 1 quantity, right? So M goes up, alright, it has to be mass M, so M and M cancel off, right? So M has to be there. Then we need time, right? Yeah, we need T minus 2 as well, so M T minus 2 we need. So what are the dimensions? M T minus 2. Mass into T minus, we don't need length, of course. Mass per unit length, no. Force on unit length, MLT, no, right, mass, MLT minus 2, right. Divide by, correct, right, MMT minus 2, right, yes. Force per unit length, correct. That's the answer, second one. Right, students, moving into the sixth question. In the equation, C is this, where C is speed, okay. LT, even its speed, it's LT minus 1, and mu, linear density. Basically, mu, linear density means mass divided by length, mass per unit length. So ml minus 1, and x would be, right. So root we have. So inside we should get, just like the previous question, we need to have inside, we have to have L squared T minus 2, right? Knowing that, so from linear density we get ML minus 1, right? So we don't need M here, so we need to cancel M. And of course mu, it's 1 over this value, so when it goes up, I hope you understand, inside the root, when this one goes up, it becomes M minus 1 and L, right. So we need to have, inside we need to have L squared value, so we need to multiply it by L, and we need to cancel this M value, and of course we need T minus 2. So this is the dimensions we are looking for from X. What is this? M L T minus 2. That's force, right? Do we have force? Yeah, we have force. D. That's our answer. Yeah, we have another, right? Yeah. First answer, that is also correct. M, this one, right? Kilogram. M L T minus. That's also correct. So A and D both are correct. That's the answer. Units and dimensions. Seventh question. In the equation, yes, that's a long equation. The dimensions of B, C are this one and this one. So what are they asking? The dimensions of A, D, E. You need to find A, D, and E. Right. Let's apply the theories. You know, D plus E. If we need to add D plus E, the dimensions of both should be equal. You should know that. And dimensions of A should be equal to dimensions of B. What's the theory behind it? So when adding dimensions, this physical quantity should be equal to this entire physical quantity. So dimensions of B should be equal to dimensions of A, and they have given it, right? B LT minus 1. So we have answer. It's LT minus 1 for B and for A as well, right? So LT minus M naught LT minus 1. First one. Do we have another? Right, M naught LT minus 1, right? So we have two. And then they're asking us from what is D. So D and E should be equal, right? So from that point as well we can check, but it's, yeah, from yeah, of course, if you use that point, actually we have the answer. It's fifth one, or else we can find it, right? Go ahead, you can try it, right? I'm not going to do that question anymore from here. It's equal, right? So that's the answer, right? Moving into the eighth question. Eighth question. Oh wait, it is a units and dimensions question. So whatever it is, let's do the question. Which of the following are vectors? So vector quantity means we need to have direction and the value as well, right? Pressure, of course, that's force divided by area. So vector divided by a scalar. So basically it's a vector, right? That's correct, right? And distance, of course, not a vector, we know that. Velocity, that's a vector, correct? And momentum, mass divided, mass into velocity. Velocity is a vector, right? So scalar into vector, that's a scalar, right? And frequency, it's 1/t, right? So time is not, we don't consider it as a vector, so it's no. So we have A, and we have C, and we have D. A, C, D, and we don't have that answer. Wait. Yeah, the answer has to be A, C, D, right? A, C, and D. And my apologies, students. Actually, I haven't given proper answers here, so that's the answer. If you find it difficult to get the answer, yes, my apologies. Moving into question number 9. The variation of velocity v with time of a certain object is given as. So here v is lt minus 1. Of course, we know that. And they're asking the dimensions of b, right? Where's b? Right. So the theory is we should know, if we need to add these, so dimensions of all of these must be equal to vector, equal to velocity, of course. So it's b over t should be equal to, it's b, right? Wait, yeah, it's b. So b over t should be equal to velocity lt minus 1. So basically we have t, right? So it goes up, it becomes t minus 1. We need only l. So b, that's l. This first one is correct. Right, moving into the 10th question, units and dimensions questions list. We are in, this question is not actually that difficult. The displacement of particle undergoing simple harmonic motion is given by x equals, right, this equation, right? So basic equation is x equals a sine omega t, and we might have phi, that's a phase, right? A is amplitude, x displacement, sine, of course you know. It's the same equation. So units of k would be, so k is this, right? So if you are familiar with the equation, actually you know what's this now. That's time into omega, right? So basically this should be the radian value. That's an angle. So radian multiplied by t and something, and we should get radian. So of course we should have radian, and we have to cancel off t, right? So it's t minus 1. That is minus 1. Or if you know the equation, you can directly write it's omega. That is minus 1. There are various ways. So if you know, if you have done questions in several methods, if you have practice questions, it's easy to get the answer, right? Moving into the next question. Right, we are in the 11th question. The time period of oscillation of gas bubbles produced due to an explosion underwater, t is this, okay, right? We don't have to be alarmed about this thing, explosion, gas bubbles and stuff like that. It's simply a dimension question. So here they are asking us the index x is equal to, okay, index of x, right? This one they are asking from us. So basically the output, it has to be time, right? Okay, d, what's d? D is density. So I'm writing all the values. Then the density k, what's k then? K is a dimensional constant, right? So from d we get density, mass divided by volume, ml minus 3, and to the power of half. And then E, that's total energy, that's force into displacement. Basically work equals F into D. This is equal to energy. This is how I find basically energy. So F into D. So F is mlt minus 2. So these are things we can easily remember, right? So ml squared T minus 2. So this is my method. If you can readily remember the dimensions of energy, that's fine. And static pressure, basically again I'm writing it from force divided by area. So that's static pressure. Where's pressure? I'll write down. That's force divided by area, right? ml minus 1 T minus 2 to the power x. So this is very basic dimensional analysis question, and it should be equal to t minus its t, right? Okay, right, let's do the simple simplification now. We need some space. I'll take this out. Yeah, now what we do, right? Okay, so it's a very basic thing actually, but we have to add all these things, m values and l values and t values, right? So here m value should get 0, and of course l value 0, only t value have 1. So we need to find, we can find from that, right? Let's dig in it. So I'm taking the m values. So first one I get half, and from the second one we get m, again m over 3, and from the third one m, it's minus x, right? So we need to add them, right? So half plus 1 over 3 minus x should be equal to m naught. So it should be equal to 0, right? So 0 equals 1 over 2 plus 1 over 3 minus x. So x should be equal to 1 over 2 plus 1 over 3, right? Common denominator is 6. So I get 3 and I got 2. It's 5 over 6. We have the answer, right? Fifth one. Alright students, we are in the 12th question. Dimension of constant a and b. A, b respectively in the equation. Okay, where mass, okay, they're asking a and b, right? So previous method, I hope you remember, this quantity, dimension of this quantity should be equal to this quantity. We know that. And x is pressure. So how do you find the dimension of pressure? That's basically pressure is force divided by area. So mlt minus 2 divided by L squared. So it's ml minus 1 t minus 2. If you have done plenty of questions, you can easily remember this as well. So it's no pressure to remember this thing. You can easily, you should remember the dimensions of force, velocity, area, acceleration, small things, right? So this value should be equal to the dimensions amt and this value as well, right? So again, to add, the dimensions must be equal. So dimension of x should be equal to amt as well. So amt, capital A, and what's m? It's mass per unit length. ml t minus 1, and t is time, right? Okay, t. So we need ml minus 1, t minus 2. So we already have m, and we have L minus 1. We need t minus 2, and we have only t here. So a, it has to be t minus 3. If only t minus 3 multiplied by t, we get t minus 2. That's my point. So it's t minus 3. Do we have t minus 3? Yes, we have t minus 3 in the fourth answer. And other answers won't give t minus 3. So yeah, we have our answer, right? But still, let's try to find b as well. B squared rho v, right? Okay, b squared we don't know. Rho, that's density, right? Density means ml minus 3 mass divided by volume. Again, what's v? It's velocity, right? L t minus 1. So from that we get, let's write it, m is already there, m L minus 2, right? Yeah, L minus 2, t minus 1, and we have b squared, right? So again, the same concept we did for a, we already have a. That's that. We need L minus 1, right? Okay, we have L minus 2 here. So we need to remove L, 1L, right? Okay, 1L we need to remove. So we need another bar L from this b squared, right? ML, okay, done. And t minus 1, we need t minus 2, right? So we need another t minus 1. So this should be equal to b squared. So then b means half value of it, right? That's correct, right? LT minus 1 half. This is the fourth answer. That's our answer. Alright students, I hope you have tried all the questions I have given. And if you find these questions are difficult, that means you have to try a lot, right? Remember that. First question, the second question will give the same marks just as the 49th question and 50th question. Yes, you need to do the 45th question, 50th question, the last question and everything. But still, even if you do the first question right, you still get the same marks. So remember that you should get first 10 questions in the MCQ paper. If you can get first 10 questions right, you will get high marks for sure, right? So work on with the easy steps first. So if you can easily do first 2-3 questions, then you'll easily get the correct answers, correct marks, perfect marks. So try easy questions first.